This is day 14 of coding every day. Um, so probably gonna be working on trying to um, finish up implementing this um, thread pool most likely, and then basically this thread pool is basically just gonna be like this group of worker threads that I can use to do different tasks concurrency without having to create threads for um, each task, aka client. Like if you come look at here, so each time a client, I am creating a new thread. So basically this is gonna have a list of like a task list, like a queue that it will go through. It will go through this queue, and then like for each, like the workers will just kind of go through this list of tasks to make sure they're empty, basically. Um, yeah, so I'm gonna be working on that. And so I was doing a little bit of research on thread pools, and so yeah, I'll probably create like this right here. I'll probably just kind of basically copy this for now before I kind of change it up to what I need. But like I'll have a vector of threads, which would be like the worker threads that I'm gonna share. I mean store. Like the queue of tasks, which I'm really just gonna have it just a queue of like the client sockets like I currently have. Um, mute mutex, which is like stands for like mutually exclusive. Um, I'm not 100% what it does. Um, I'm probably gonna be reading about it here. Basically, just kind of trying to figure out what mutex really does. And then oop, right here, condition variable. This is just what is going to be used to like signal changes of the task queue. So like if one gets added, it can be used like right here to notify a thread, and then probably a stop when like the thread pool should finish up or anything like that. So for now, what I'll do is I'll kind of just put that over into my code. So right here is gonna be my task list. Um, so I want a vector of threads. Um, probably call this workers, maybe. Should I call it workers? Yeah, I'll probably call it workers. Well, then I'll also need to include thread. Um, yeah, that was weird. Um, and then I'll need a condition. Oops, condition variable, which I'll call CV. Then I need to include that as well. Include um, condition variable. Oops, variable. So then I have that, and then I'll need as well that. I'll call it stop. And actually, I'll put it above here. So it's gonna be that like it says on this, it's gonna be that mutual exclusive and mutex. Um, so I'll have to include that. Include mutex. Yep. And then do that. This mutex. then I'll call this like, on this it calls it QMutex, so I'll just call it that, QMutex. And so I have the um, different private data point that I'll need. And so I'll have the, um, what's it called? The constructor, the um, destructor, and then the queue. So I think that's all I really need to start implementing it. So what I'll do is I'll go to this. So I have queue, thread pool. So, okay, so let's see. Um, so in the creation thing, let's see. I'm gonna look real quick to see how it creates this. So it does threads. So it does the, um, yep, threads dot emplace back this while true. Reason for putting, let's see. So just reading what it says right here. The reason for putting this below code is to unlock the queue before executing the task so that other threads can perform before executing the task so that other threads locking the queue so that the data can be shared safely. Unique lock. Waiting until there's a task to execute or the pool is stopped. Okay. Exit the thread in case the pool is stopped and there are no tasks. Get the next task. Okay, wait. Exit the thread in case the pool is stopped and there are no tasks. Okay. And place back. So I'm not really sure what that does. Let's see. And place back. Yep, it's going to be a vector. Appends a new element to the end of the container. The element is constructed through, yeah, which typically uses placement new to construct elements in place at the location provided in the container. The arguments are forwarded to the constructor as, okay, again, okay, so it's going to be like, place back. Seems like it just really just adds it to the end. Well, it says it, yeah, appends a new element. So it looks like it creates. So let's see. Use pushback when you have an existing temporary object that you want to move into, or more generally, use pushback when you want to move an existing object. Okay, so I see. So it's creating, um, so that's the open bracket, or open parentheses, and that's the end parentheses. So this and all this. So it's creating these temporary, I guess, um, arguments to forward constructor. If possible, constructs an object of type T and allocated pointing to a P by calling. Okay. Um, Not 100% sure I understand how that works, but I guess I'll just kind of copy it. So, for, huh, okay. Well, start just implementing this code and hope I can understand it. um, as I go. But so let's see. So for here, I'm gonna do. I called it workers dot emplace back, and then I want to do this. I want to do yep this, and then we'll do that for now, and then it's gonna be curly brace. I'll probably do that for now. There's a copy kind of what that says, but so it's gonna be a while loop. It's just while true. It's an infinite kind of loop. Um, let's see. Um, here this. Yep. Uh, while true, and then inside this while true, inside this while true, looking at this code, it does the function void task. So, so this basically makes a instance of a task, but my instance of a task is going to be my instance of a task is going to be the client file descriptor. Yep, client file descriptor. Then I come here. So after it does that, it opens a curly brace. Not sure why. Let's see. Open this curly brace. After the wait. Huh. Hmm. Maybe I'm not familiar, but it looks like it puts a portion of code just inside of a curly brace. So it's going to be that, oops, unique lock, and then it's going to be mutex. If I could spell, that'd be awesome. Let's see. So unique lock controls mutex ownership within a scope. Ownership of mutex can be delayed until after construction and can be transferred to another unique lock by. Not 100% sure, but and then I'll just lock, unique lock, and then I lock the Q um mutex. I think I called it. Let's check. Q mutex. Yep. So after I lock it, it wants me to do my. It says to wait, and then I wait. It says lock. So this looks like this is the point where we wait until there's a task or the pool gets stopped. So, oops, this, and then um, so this, then I want to return, oops, return if tasks, I think I call it tasks, task list. If task list dot, so if it's empty, not in place, empty. So if it's empty or stop, okay. And then, so the wait is a function. Let's see. pool, unique lock. I'll have to look into that in a second. I was going to continue kind of copying what this is. So if stop, if stop and task list is empty, then I want to just return. And then I want to do, and then it looks like get the next task from, get the next task from the queue, which I have. So it looks like it just does, um, so client FD equals tasks dot front. So move task dot front, and then not tasks, sorry, task list dot front, and then task list dot pop. Um, and then after that, it says to run task, but task is a function, but really I want to run, okay, but really I want to run this client through, I want to run every client through the same function. That function will be handle client. I see, so I actually think I will have to move this handle client over into this thread pool implementation. For now, I'm just gonna leave it like this and just pretend like I'm running it through, um, uh, running the client through, and then just pretending I'm running the client through that. Um, and let's see. So I'll pretend like that, and then that looks like that's it for the creating the threads. And so let's just go to the deconstructor, which is the next thing here. And so it looks like so, okay. So it looks like I need to unique block mute exclusive, grab the, and then, oh, wait, grab this as well. Okay, so I need to do um, I need to lock the queue. So I will lock the queue mutex. Yep, so I'll lock that. I'll set stop equals to true. So basically I want to stop. Um, and then I want to all notify all of the threads, and then and then I want to join them all to make sure they finish. So it's gonna wait for them to all finish. So for, let's see, I can do thread. I'll call it worker in workers or worker and workers. I just want to do worker.join. So I join them all, and I should be able to deconstructor because then this just what's it called? It just when I join them, it just makes sure that they all finish their task. Kind of ends up waiting for each of them to finish and then joining back to the main thread. I believe that's what that means for join. Like it's just gonna wait for the thread to finish and then goes into that main thread. And let's see. Okay, so for the thing, but since it's locked, it says. So okay, so it looks like for each of these mutual exclusive stuff, there's this brace. So I'm gonna really have to look into what this unique lock, mutual exclusive lock, and everything like that really means. But for now, I'm just trying to um, to like, sorry, I'm blinking. I'm trying to get just the implementation started right now. Then I can go through, kind of figure out what I need to do and like what I need to look at to get working. Um, so it looks like it's another unique lock. Huh. Just trying to figure out what each of these mean, but I'll just do another unique lock. Um, let's see. It's going to be mutual exclusive, and then I'll lock the queue. Yep, I'll lock the queue, and then I'll do um, so I want to push it on, so it's going to be task list dot push. Then I want to push the client file descriptor, and then I want to just notify a thread that something has been added to the queue, and then that looks like that's about it, really. Um, so it looks like okay, so I actually do need the queue. So I do need the queue of stuff because let's see, let me go through this real quick. I forgot. Task list push up here checks the task list empty, and if not, I take it from the front and then I pop it. Then I run through client, which I will move over to this function. But let's see. Trying to figure out how I would actually get it to work. So if I move handle client over, or let's see. No, because I want to do this here just so I can copy the implementation. So I do have to move handle client over. But if I do move handle client, then if I look at my server, so this is where handle client's happening. Um, so I think, let's see. Well, because, so after the accepted, I get a new client file descriptor, and then I can add that client file descriptor to the queue. Yeah, so then I can add it to the queue. I should call this enqueue, by the way, just to, because that's the proper term. But so if I add it to the queue, and then the thread pool does the the stuff for me. Like it will do the handle client. So all I need to do is add it. So I need to add each of these accepted client file descriptors to the queue. So to do that for queue, I need to pass the client descriptor. So what I probably need to do is like, um, it'll have to be like, I'm gonna put this in the comment for now, but like thread pool, I'll just call it TP. TP, so like thread pool dot in queue, and then like, I'll just call it accepted for now. I know it's file descriptor, but like accepted client file descriptor. I believe that's all I really need to do, right? Because I want to pass that, and then this should run that handle client on it, and then like this right here just does that client finish. Oh, I actually had it right here. Oh, oops. Was not paying attention. So yeah, that's basically what I want to do. So how do I get the, so if this is an object, right? So this is an object. If I put it inside main, and then I start, create it, so I'll create a thread pool of like, let's say, I don't know, 10 threads. So I create a thread pool of 10 threads. But if I want to use a thread pool, I need to somehow put it inside this right here, inside this function. So maybe I can pass in a thread pool. What am I gonna call it? Is it just capital T, lowercase? So like thread pool, and I'll call it TP. Sure. But I think that means I need to include thread pool. Do I need to include thread pool? Identifier thread pool is undefined. Well, since this depends on thread pool, then I'll have to include it, right? Include thread pool header. Okay, yeah. So thread pool TP. So this passes it by value. Is that what I want to happen? Well, kind of like copies the thread pool, right? So we just want the address of it, so I can use the same thread pool. And then I do like this. Then I'll call it client file descriptor. And then I just kind of do this, and then I need to go to my um, server.h, and then inside my, not handle client, but inside the start, I need a thread pool, and then um, hashtag, or not hashtag, TP. What if I call it tpool? Just so it's a little bit more clear what it actually is. Come to server, tpool, tpool. I think that might be it, honestly. Well, I need to include the handle client right here inside the thread pool. But I think that might be really all I need. Um, huh. Let's see. Do I need to include these in here? Or do I include them here? Does it change anything? Okay, it does. Just checking. Yeah, cause I need these in here. And also this like, if and def define stuff, just basically make sure that I don't have like repeating libraries or anything like that. Like, I mean, there's not really, I don't think there's really any repeating here, like between these two. Or thread. Well, that's only for now, I think. So I get rid of, cause I get rid of this, I think I don't need threads, because if I just move it over. But, so like, they just make sure that there's no like repeating. So like with thread, it's not being included twice, basically. But, that might be it. I will probably need to do for server dot header. But we need to do this handle client, which I'll just do like this for now. I'll implement it next time. This handle client. Um, for now, that should probably be it. But let's see. I'm just gonna read over um this like lock stuff that we kind of just worked on, like this lock, unique lock, grant that, and let's see. Um, so locks the mutual exclusive. If another thread has already locked the mutual exclusive, a call to lock will block execution until the lock is acquired. If lock is called by a thread that already owns the mutex, the behavior is undefined. For example, the program made deadlock. An implementation that can detect the invalidates is encouraged to throw there. Okay, let's see. So look, we use unique lock. The general purpose ownership wrapper allowing deferred locking, time constrained attempts at locking, recursive locking, and transfer lock ownership. The class unique lock is movable but not copyable. The basic. If mutex meets the lockable requirement, unique lock also meets the lockable requirement. So the type of mutex to lock, type must meet the basic lockable requirements, and then lock. So lock is like takes ownership. Let's see. So let's see. So if lock like takes ownership, and then Q mutex is just a standard mutual exclusive. So what look like a mutex here is a class of synchronization primitive. Is a synchronization primitive that share data for being simultaneous access by multiple threads. A calling thread owns a mutex for the time that it will either lock or try lock until it calls unlock. When a thread owns a mutex, all other threads will block for calls to lock or receive a false return value for try lock related. A calling thread must not own the mutex prior to calling lock or try lock. Destroyed while still being on binding threads, or thread terminates while owning the mutex. So it looks like it's just like it's something that's used to protect data from being accessed at the same time. So like, let's say it's like this list of data that like one thread doesn't overwrite something that another thread might use. It looks like it's used for. Um, so I'm trying to see. So if it does like unique lock of mutual exclusive, and then it locks the thread pool or unlocks Q. I'm not sure. I just don't really understand what like this like Q mutex is for really. And then this unique lock, I'm not 100% sure either. But there's also that wait function that is used. Yeah, it's right here. Wait causes the current thread to block until the condition value is notified or support spurious wake up occurs. Predicate can be conditionally provided to detect spurious wake up. Atomically calls locked on lock and blocked on this. The thread will be unblocked when notify all or notify one is executed. It may also be unblocked spuriously. When unblocked, calls lock lock, possibly blocking on the lock, and returns, equivalent to while pred wait lock. Right after. So let's see, wait, a lock which must be locked by the calling thread, the predicate to check whether the waiting can be completed. Okay, so it looks like calling thread. So, and then a predicate to check whether the waiting can be done. So with ours, so the lock, yep, so it has the lock, and then it basically is going to check if stop or if it's not empty for the predicate, something like that. um, okay, it's really confusing. I think I'll probably have to research this more a little bit, probably like tomorrow. I'm really trying to also, I think I'll also implement that handle client tomorrow. Well, not really implement it. I'm just gonna move it over basically to the thread pool, and then after I move it over to the thread pool, I'll probably check to make sure that this works. Here, I'll probably need to put in a thread pool, but I also need to create a thread pool as well. So I'll probably do that tomorrow, but I think on this implementation a little bit, I'm probably gonna research a little bit more on this, what this mutex and everything is. Kind of a lot for my head right now, but looks like I have the thread pool implemented. I understand it from a high level, just not really sure what all these different components are. Um, like I'm just not 100% what this lock and unlock mechanic is. Like I get that, what's it called? Like here, client, and then like it goes through the queue. Like this basically is just gonna make it wait until on like on this lock, I guess, until like it's not empty or if it's been stopped. But then if it's stopped and it's empty, then it just returns. But if after the wait, so let's say it's not empty, because then it'll go through this, then make it'll just set the client FD from the front of the list or front of the queue, and then it pops it to just so it doesn't get like duplicated, like it doesn't keep doing the same client over and over and over. And then I'll do the handle client, and then for like this in queue, basically it's just like it basically just pushes it. It basically just really just pushes it onto it basically just pushes it onto the queue or like the task list I called it. But then it notifies one, so basically notifies a thread, and then here just notifies all the threads and it just makes them join. So it just waits for each thread to finish what they're doing as they join to the new thread. It's also just set stop to true. But like I understand from a high level, just not 100% sure with this locking and everything like that. I kind of think I get it, where it just makes sure that like multiple threads aren't accessing the same data. So possibly like it's just to make it thread safe. Like if one thread starts like overwriting this data, and then the other thread pulls it, it just kind of just like messed up, I guess. But I'll probably read about it later. But that'll probably be it for today. I think that was day 14. Probably finish just this handle client stuff and then like this main function. But for now, that'll be it today. And see if I can finish this up tomorrow. And then honestly, that should probably be it after that. And then I'll probably start working on a little bit of some embedded stuff. Got an Arduino to try out. Um, Probably just work on some embedded after this. But yep, that'll be it today.